Two cars enter the Florida Turnpike at Commercial Boulevard at 8 a.m., each heading for Wildwood. One car's average speed is 10 miles per hour more than the others. The faster car arrives at Wildwood at 11 a.m., half an hour before the other car. What is the average speed of each car and how far did each of them travel? For a uniform motion problem, I recommend drawing a 2x3 box to help organize the given information. We'll say that one of the rows is going to be labeled and dealing with everything to do with the first car, and then the other row will be labeled and hold all the information for the second car. Our column headers are going to be arranged such that the first two columns will multiply together to give me the third. So what we'll label these column headers with is rate times time, and that's going to give me the distance. So this is the arrangement of our table that's helping us to organize the given information. Now let's read back through the problem to see if we can identify any obvious information that can be put into the table. Two cars entered the Florida Turnpike at Commercial Boulevard at 8 a.m. That is not obvious. I'm not sure where to put that in the table. Each headed for Wildwood. One car's average speed is 10 miles an hour more than the other cars. The faster car arrives at Wildwood at 11 a.m., half an hour before the other car. What is the average speed of each car? Well, none of that information is obvious where it goes in, but the unknown quantity, what is the average speed of each car? Let's say the speed of car 1 is one of our unknown quantities, and the speed of car 2 is the other unknown. We're basically identifying our unknown quantities by looking at the last question to identify the unknowns. Now, one of these unknown quantities is going to get the variable x. And also one of these cars is faster than the other. So I'm actually changing my mind about calling it speed of car 1, and instead of calling it car 1 and car 2, as a matter of fact, I think that what we'll call it is the fast car, because one of them is 10 miles an hour more, and the slower car. Car 1, car 2 was pretty generic, but so we can get a little bit more descriptive if we call one of them the fast one and one of them the slow one. Now we need to decide which of the cars is going to get the x variable, the variable for the unknown quantity. And because we have the information that one car's average speed is 10 miles an hour more than the others, it makes sense to give the slow car the x, so that then we can say that the fast car was x plus 10, or 10 miles an hour faster than the slower car. So since these are our speeds, we're going to put them in the rate squares of our table. Now, when we read the problem initially, we weren't given exactly how much time each car is traveling. So in order to determine what we're going to put in the time cells, I'm actually going to draw a little picture to kind of help us get this sorted. So here we have the fast car and the slow car, and they're both entering the Turnpike at Commercial Boulevard, and they both begin at 8 o'clock in the morning. We know that the faster car arrives at Wildwood at 11 a.m. So the faster car arrives at Wildwood. Well, that tells us that the time the faster car was driving was 3 hours, right? From 8 o'clock to 11 a.m. We also know that this arrival was half an hour before the other car. So the other car must have arrived at 11:30, half an hour later, which means that the slow car traveled for 3.5 hours. And these are the values that we're going to put into the time cells of our table. And now that we have two columns populated, we've got our rate column and our time column populated, this is where we're going to want to multiply across to fill the distance cells. So we're going to multiply these two columns together in order to come up with that distance. So we'll say this is going to be 3 times x plus 10, and this one's going to be 3.5 times x. And now it's time to create our equation. And what we know about the distance that each of these cars traveled was that they both entered and exited the turnpike at the same place. So the distance of the fast car is going to be the same as the distance that the slow car traveled. So essentially we're going to take these two distance quantities and set them equal to each other to create our equation. So here we have the distance of the fast car was 3 times x plus 10. Distance of the slow car was 3.5 times x. We've set these two things equal to each other, and now we just solve for x by distributing the 3 into the parentheses is equal to 3.5. We're going to get our variable terms to one side, so we're going to subtract 3x from both sides. That's going to leave us with 30 over here on the left and 0.5x on the right. 3.5 minus 3 is just going to be 0.5. And then when we divide both sides by 0.5 to isolate the x, we're going to end up with x being equal to 30 divided by a half is 60, and since our x value was the speed of the slow car, then we're going to put the units of miles per hour onto our answer. And let's then go back up to the original question to be sure that we have fully and completely answered it. It said as a question, what is the average speed of each car? So we actually need to go a little bit more here. We'll say that the slow car was 60 miles an hour, which then tells us that the fast car must have been 10 miles more than that, or 70 miles per hour, right? The second part of the question is how far did each of them travel? And since the distances were the same, we could actually compute the distance using either the fast car or the slow car here. So we can take the x value, and the slow car's distance was 3.5 times x, so that's going to be 3.5 times 60, which is 210, and distance is going to be measured in miles. So the total distance traveled by each car was 210 miles, and then the rate or the speed of each car was 60 miles an hour for the slow car and 70 miles an hour for the fast car.